This is Algebra I, Section 1.7, Functions, on page 49. Sorry I didn't dress up, but hopefully I'll be able to get the information to you looking like this. We're going to talk about functions. And the last lesson you learned about relations, and functions is one step further based on this. Functions are relations in which every x value is paired with exactly one y value. Okay, so in other words, every member of the domain has exactly one member of the range. And we're going to look at some different types of functions as we proceed. But all functions are relations, but not all relations are functions. So keep that in mind. The first one I want to look at is something like this, where I'm going to use different ways to do it, and we're going to do a mapping because we found out that we can do a mapping on a relation. So I'm going to look at this one. Okay, here you see the x values and the y values and in a relation, and we see that a -2, 0, and 3, 4 are all paired with exactly one value. Now I realize that 0 and 3 go to the same value, but still they are paired with exactly 1. Now, so this is a function. It is not a function if we would have something like this, where we have 2, 3, and we have 4, 5, and we have the 2 paired with the 4 and the 5, and maybe the 3 paired with this. The problem is not the 3 and the 2 going to the 4. The problem is that the 2 is going to 2. So this is not a function, okay? And as you look, so that we'll just put no. As you look at functions, they can represent different things, but I want to show you graphically what the problem here is. I'm going to look at that. We have basically 3 ordered pairs. I'm going to write them as an ordered pair so you see them a little bit differently. We have 2, 4. We have 2, 5, and we have 3, 4. Okay, I want to look at these points on the graph. If we have 2, 4, we have this one, and we have 2, 5, we have this one, and we have 3, 4. The problem is these 2 points, okay, not these 2. So in a graph, these are called horizontal points, and we don't connect them, they're just points, okay? These 2 particular types of relations are called discrete. Now, normally we just keep the word discrete with a relation, or with a function. So this one is discrete. This one, since it's not a function, we probably wouldn't call it that way. But any set of ordered pairs where we don't connect them is called a discrete relation, a discrete function. But it's these 2 that have the problem, okay? They're in any type of graph, okay? We have what we call the vertical line test. And it's kind of misleading because it actually tests for what it isn't. It says this: if a vertical line can be drawn such that it intersects 2 points, 2 or more, I better put or more points on the graph. Now listen to this. The graph is, for emphasis sake, is not a function. Okay? It's not a function. All right. So the vertical line test says if we can draw, and you can see I can draw a vertical line such that it intersects these 2 points, and it's 2 or more, then it is not a function. Okay, and this works for discrete. It also works for continuous, which I'm about ready to talk about. But I want to look at another one because they show this in this form, and I want to show you a different form. We want to do a t-table, okay? And their t-tables, well, maybe I'll show you their t-tables. Their t-tables can go left or right. I'm going to do this one because we haven't done one like this. 1, 4, 3, 2, 5, 4, and a -1, 4. Okay? If you look at this, whoops, this is 1, 4. Did I copy 1, 4, 3, 2, 5, 4, 1, and -4? Okay, my bad. If you look at this particular, this is also a discrete relation because it is a set of ordered pairs, okay? But if you look here, here's the x values. This x and this x are the same, and they're going to 2 different y's. So this is not a function, okay? And it's just a different way. So we can write them as a mapping. We can write them as a t-table. Okay. The next particular thing is we can graph them. And so I'm going to stay away from the graph so you can see this better. We're going to talk about a continuous function. I hope I spelled that right. It doesn't look right, so I'm going to look it up. Continuous. Okay, continuous function. One of the ones that I like to use is a parabola. Okay, a parabola is, and by the way, this is a different representation. We have mapping, we have a t-table, now we have a graph. Okay, so it's a different representation of what a relation or a function can be. This is a parabola. This is a standard parabola. You can see that anywhere we draw a vertical line, that it passes the vertical line test. So this is a function. Okay, this is a function. Now, oddly enough, if I take this parabola and I turn it around, or I turn it sideways, then this is not a function, okay? Because I can draw a vertical line and it touches 2 points. So anytime you can draw a vertical line and it touches 2 or more points, it is not a function. We have all kinds of ones that we can look at. One of the ones in the book is it has like an absolute value type thing. This is not a function, okay? Why? Because we can draw a vertical line, it touches 2 or more points, okay? Another one is like this, and this is what we call a piecewise, and it has an open circle here going right, and then a closed circle here going left. And this is actually a function. It's called a continuous function. So yes, this is a function, okay? Because the vertical line, this is an open circle, so the vertical line actually can be drawn here, but it only touches 1 point here, and then the rest of the points it just touches. So this is kind of one that's interesting. So once again, I'm just going to run through this. We can have a discrete relations that are functions, and then we can have discrete that aren't. Okay, we can have continuous functions that are, okay, and then we can have them that aren't. Okay, I will tell you this: all lines are functions except vertical lines. Vertical lines are not functions. The rest of them are. Okay, so you need to know those things. There's one last way that so I want to look at a vertical line, or excuse me, I want to look at a line. If we have y equals 3x plus 5, okay. If I look at this line, all right, this line is a function because it is not vertical, and we'll explain later what vertical lines are and what vertical lines aren't. But all lines are, okay? So any line in this form is a function. If I have a y equals 7, this is a horizontal line, okay? It is a horizontal line, and it is also a function. How do I know it's a horizontal line? Because I have y equals some number. So if I go over here, y equals 7 looks like this. Just so you want to graph it quickly. 1, 2, 3, 4, 5, 6, 7. All horizontal lines are functions. Okay? Now, how do I tell one that's not? So these are all functions. Here's one that isn't. X equals 3. Anytime we have just x equals some number, this is a vertical line. Okay? If I wanted to graph it for you, I could go over here and I could graph it like this. And it is a vertical line. It fails the vertical line test miserably. It has infinite points that are vertical. So these two lines, anything in these two forms are functions. And this is not. Okay? All right, just so you know that. So anytime you see a y equals, if you see an x and a y, you're safe. But if you see just an x equals some number, it is no. Okay? All right. The last thing we want to talk about is how to solve functions and how to write them. All right? Lines are written like this. I'm going to take that one up there. And then what we do is we replace the y with this. F of x equals 3x plus 5. So what this says is this is a function of x, and we're going to plug values in for x and get values back for f of x, which is replaced by y. So f of x, quite simply, is a fancy way of writing y. This is what the book would call an equation, and this is called functional notation. Actually, I think they just call it function notation. Okay, and all we do is we replace the y with f of x. So let's take a look at this. I'm gonna choose a different one, a little bit more complicated. Let's say that we have a function. By the way, f of x is used, but not all the time. We can use g of x, h of x, all kinds of letters, but most of the time f of x is used for function. So let's say that f of x equals a negative 4x plus 7. Okay? This is the hard part. This is the part that most students struggle in. If we wanted to say f of 2, okay, so what we're saying is, since this is a function, it's like, what are we going to put into the function? And that's what this is. We're going to put this 2 into the x of the function. So what we get is a negative 4 times 2 plus 7, which is a negative 8 plus 7, which is a negative 1. So 2 and negative 1 is an ordered pair on this function, okay? And I could write it as 2 and negative 1. It's not necessary to write it, but I want you to know that this is a point on the graph, okay? 2 and negative 1. What if I said, what is f of a negative 3 plus 1, okay? So now, this is a function that we're going to put a negative 3 in, and then we're going to add 1 to the whole thing. So what I'm going to do is I'm going to take a negative 4, and I'm going to plug this into that. It always goes in for the x, and then I'm going to do a plus 1. So now I have positive 12 plus 7 plus 1. So I have 12 plus 7 is 19, 20. So I have 20. So there's different kinds of things that we can do, okay? I can do this. I can go, what is f of a negative 1 plus f of 2, okay? All right, so what it says is, hey, put a negative 1 in the function, put 2 in the function, and then add those two together, all right? So I'm going to do this. I'm going to go f of a negative 1, so I'm going to put a negative 1 in there, so a negative 4 times a negative 1 plus 7. Don't forget the plus 7, that's still part of the function. Plus, and then I'm going to put 2 in. So this is the first thing I do. That's the first thing I do. And the second thing I'm going to do is I'm going to put 2 in. So I'm going to put a negative 4 times 2 plus 7. And then I'm going to simplify. My writing is not very good. Negative 4 times negative 1 is 4 plus 7. Replace it with parentheses, and a negative 8 plus 7, which we've already done. A negative 8 plus 7 is, we got a negative 1, right? So I have 11 plus a negative 1, which is a negative 10. Okay? Now, not all functions are that easy. And you might say, well, that's pretty difficult. But we actually have harder functions. We have functions that involves powers and things like that. For example, let's say that I'm gonna change this. I'm gonna go h of t. Okay, so this function's name is h. My variable is t, so it's a negative 16t squared plus 68t plus 2. If you use something like this, So oftentimes this is used in science, where we have values like this, physics, things like that, motion. So now we're going to say h of 4, and often t stands for time. And so we're going to put 4 in here for the t's. So we want to find h of 4. I'm sorry, I wrote that wrong. H of 4 equals a negative 16 times 4 squared plus 68 times 4 plus 2. Now you'll notice that I have two t's. One is squared, one is not, and I put the 4 in for both of them to figure this out. So I have a negative 16 times 16, which I believe is a negative 256, plus 32, 3, 24, 272, plus 2. I'm going to double check that just to make sure. Maybe you should do that too, because I don't want to send you away thinking that this is the right answer. 16 times 16, I believe, is 256, and 68 times 4 is 272. So I have now 256 negative plus 272 plus 2. And my value is 18. Okay, so this is 18. All right, so when I put 4 into this, I get 18 back. It's like a factor. You put 4 in, what do you get back out? Now I'm going to look at a little bit more complicated one. This one says 2 times h of g. Okay, now you can see that g is not t, okay? But g goes in for t. So not only can you put numbers in for t, but you can put other letters in for t. So what I have is 2, don't forget the 2, times, and I'm going to put this g into all the places that t is. So a negative 16, a negative 16 g squared plus 68g plus 2. So what I did was I put the g in for this t and this t. That's what it says. Put this in here and here, okay? And now I'm going to simplify it by distributing, remember the distributive property, this 2 into everything. So I have a negative 32g squared plus 136g plus 2. And so my answer is not a number, it is a quantity, okay? So remember, we're just to give you a little review, we talked about functions can be written 4 different ways. They can be written as a t-table, a mapping, a graph, or an equation, or a functional notation, either one. Okay, we have 2 types of functions. We have a discrete function, or a relation that just has points and they're not connected. We have a continuous function that does have lines. Okay, some of them are functions, some of them aren't, some of them are just relations. We have a vertical line test that helps us with the continuous functions. If we can draw a vertical line through 2 or more points in a graph, it is not a function. Okay? And then we talked about functional notation. Oh, we did talk about lines. I'm sorry. How all lines are functions that have a y and an x. The only ones that aren't functions are when we have x equals a certain number. X equals 5, x equals 6. These are vertical, these are not function. All the rest are functions. So if you see a line with just x and y, it's a function automatically. And then we talked about functional notation. We talked about how to find the value in a function. And we also talked about how, if we're going to put a variable into a function, how that comes out. So this concludes our problems on functions.